but got it. I would like you to try to pause the video and try it yourself, and then listen to me walk through to see if you did it the same. But again, that's going to be up to you. There are 6 students in a classroom with 8 desks. How many possible seating arrangements are there? That's a pretty good question. We could do something like that for our class. You know, if I have 25 seats and I have 19 of you guys, I could do something just like this. Of course, the number that I could do is outrageous. We can handle this number. So the order, since we're dealing with arrangements, order is important. Okay, that's going to become very important as we move on to combinations. So I use permutations. I have 8 desks total. I only have 6 of them that I need to use. That's 8 factorial over 8 minus 6 quantity factorial on the bottom. The top is 8, 7, 6, 5, 4, 3, 2, 1. The bottom is just 2, 1 because 8 minus 6 is 2. And somebody always asks, I say, Miss Langeli, could I do 8, 7, 6, 5, 4, 3, 2, 1 minus 6, 5, 4, 3, 2, 1? No. You have to subtract first and then bring over the factorial on the bottom. So the 2 1s cancel. And now you just have to multiply 8 times 7 times 6 times 4 times 3, 3. And if you can imagine this, if I only had 8 desks and 6 students, look how many seating charts I can make. I can make 20,160 seating charts in my room. Isn't that crazy? Okay, moving on. Last page deals all with combinations, and we saved the best for last because combinations are just a tad bit more difficult. The formula you learned is combinations n of r is the number of items you have factorial over, now you still have the parentheses on the bottom, n minus r. But in front of the parentheses, this time you have the extra little bit, which is why combination is always smaller. Combination is always smaller because you are dividing by something else, and that something else is the r factorial. Now let's try this. 20 people report for jury duty. How many different 12-person juries can be chosen? Notice order is not important. We are just talking about groups. We are not ordering anybody. We're not saying what seats are they going to sit in. That makes it a combination problem. 20 people, 12 of them are allowed to be chosen. Now this might be fun for you to take a guess. How many ways do you think that this could happen? How many different groups could there be? I would encourage you to write down your guess. See how close you are. Combination. So we do 20 factorial on the top. Please follow carefully as I do this. On the bottom, I have to put the 12 factorial in front of the parentheses, and then in the parentheses, I do 20 minus 12. So it is very similar to permutation, but it is actually very, very different as well. All right, we need to really work this out. Go slowly with me. The top will be 20 factorial. I am not writing it all out at this particular time. Over 12 factorial and 8 factorial. Now I'm going to write this, but I'm going to write it out really long. Here we go. Keep it small. In fact, let's write it down below. The numerator will be 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Well, that was painful. All over 12 factorial. Oof. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And 8 factorial times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Pause the video if I went too fast. Make sure you got all your numbers copied down. This problem is extremely long, but we're going to talk about how you can shorten it up. If you're pretty good at math, you should be able to do this. I want you to see how, now what's bigger? This section that I'm underlining or this section that I'm underlining? The 12, right? 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Absolutely, the 12 one's longer. So what we're going to do is we're going to cancel 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 with the top. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Whew. Well, that makes it easier. Now, keep going, guys. I know you can. What if I cancel 5 times 4 with this 20 up here? Well, isn't 5 times 4, 20? All right. Keep going. What if I cancel, let's say, the 8 and the 2? Isn't 8 and 2, watch this, 16? Okay. Let's say I cancel the 6 and the 3. Isn't 6 and 3 18? Absolutely. Now let's see, what's the only number I haven't got rid of yet? 7. Well, can't I cancel the 7 with the 14 and make it a 2? Absolutely. So you notice I was able to cancel everything in the denominator. After I do that, I'm going to grab my calculator, and you guys could have canceled different things than I did. These are just the numbers that I chose personally to cancel. Okay, calculator, multiply all the things that are left in the top. 19 times 17 times 15 times 2 times 13 equals 125,970 different committees that could be formed. So that was 125, 970. That is a lot of different ways that the jury will say there's that many 12-person juries. That is crazy that out of a group of 20, if you're picking any 12, that is how many different types of juries you can have. Okay, continuing on. In the guided question, it asks how many different types of ways can you choose 3 types of flowers from a bouquet from a selection of 15. Something to make mention is that this is just a group of flowers. There's no order. So we're going to use combination of 15, selecting 3. The top number is 15 factorial over. Since it's this combination, you put 3 factorial on the outside and 15 minus 3 on the inside, and factorial. The top is going to be 15 factorial, and the bottom becomes 3 factorial times 12 factorial. Now I want to show you a shortcut here, okay? Which of the bottoms is bigger, 3 or 12? Hopefully you say 12, right? 12 is a lot bigger. So watch what I'm allowed to do on the top. I'm allowed to write 15 times 14 times 13 and stop. Why am I stopping? Because if I kept going 12, 11, 10, 9, so on and so forth, it would cancel with this 12, 11, 10, 9, so on and so forth. So what I'm going to do is I'm going to save myself a lot of writing, and I'm just going to cancel out this 12 and pretend like it already canceled with this 12 up here. So the new bottom is just 3 times 2 times 1. Now this isn't bad, right? You don't even have to cancel out if you don't want to. If you want to cancel the 15 and the 3, go for it. Or just multiply the numerator. 15 times 14 times 13. So we get 2730 on the top. And on the bottom, you get a whopping 6, because 3 times 2 times 1. Now if you divide this out, you get your final answer of 455 different, we can write different 3 flower bouquets. All right. We're going to move on. We're going to try this one more time. And we're going to do one more combination problem. We have a toddler preschool class. There are 15 toddlers in there. That's a lot of toddlers. How many different groups of 8 can be chosen to play outside? Aw, so 7 of them don't get to play outside, I guess. All right, here we go. We take our combination, and we need to have 15 total, 8 of which get to go outside, I guess. So we do 15 over 8 factorial times 15 minus 8 factorial. We reduce that to 15 factorial over 8 factorial, 7 factorial. Just like I did above, I'm going to cancel out the 8 on the bottom because it's bigger. The top will be 15, 14, 13, 12, 11, 10, 9. Notice I'm not going to do 8, 7, 6, 5, 4, 3, 2, 1. And the bottom is the remaining 7. 7, 6, 5, 4, 3, 2, 1. Now let's cancel some items out. I know you know that 7 times 2 cancels with 14. How about 5 and 3 cancels with 15? You can even go as far as to cancel 6 with 12 and make 12 a 2. And you could keep going. You could like cancel 4 and 2 and do all that. But let's just go ahead and multiply the numerators, what we have left. So I have 13 times 2 times 11 times 10 times 9. So the top is 25,740. The bottom is a whopping 4. So I take my answer and I divide it by 4, and I have a final answer of 6,435 different groups of students who can go outside. And that's all there is to combinations and permutations.